Hello everyone. Today we are going to see about the sorting, different sorting techniques. How to pick what is a particular sort. Let us see about sorting. What is sorting? Sorting means arranging the elements of an array so that they are placed in some relevant order, in which may either ascending order or descending order. That is, if A is an array, then elements of A are arranged in a sorted order in such a way that A of 0 less than A of 1 less than A of 2 up to A of n. Because you already know array is array will start from a of 0 to a of n. The practical consideration for different sorting techniques would be number of sort key comparisons that will be performed, number of times the records in the list will be moved, best average and worst case performance, stability of string sorting algorithm, where stability means that equivalent elements or records retain their relative positions even after sorting is done. Various sorting techniques are insertion, selection, bubble, merge, quick, tree, heap. Let us see the insertion sort first. The insertion sort, the sorted array is built one at a time. The main idea behind the insertion sort is that it inserts each item into its proper place in the final list. To save memory, most implementation of the insertion sort algorithm work by moving the current data element past the already sorted values and repeatedly interchanging it with the preceding value until it is correct place. Insertion technique. Insertion technique, the array of values to be sorted is divided into two sets, one that stores sorted values and another that contains unsorted values. The sorting algorithm will proceed until there are elements in the sorted set. Suppose there are n elements in the array. Initially, the elements with index 0, lower bit in the it is sorted set. The rest of the elements are in an unsorted set. The first element of the unsorted partition has an array index 1 if low bit equal to 0. During each iteration of the algorithm, the first element in the unsorted set is picked up and inserted into the correct position in the sorted set. Insertion sort procedure. Recursive algorithm repeat the step 5 for pass 1 to n minus 1. Initialize a temporary variable to compare with temp is equal to k of pass. Compare, move the minimum value element to the start of the array. At last, stop. Analysis of insertion sort. The best case input in an array of that already sorted. In this case, insertion sort has a linear running time. During each iteration, the first remaining element of the input is only compared with the rightmost element of the sorted subsection of the array. The simplest worst case input in an array is in reverse order. The set of all worst case inputs consists of all arrays where each element is the smallest or second element, smallest of the elements before it. In these cases, every iteration of the inner loop will scan and shift the entire sorted subsection of the array before inserting the next element. This gives insertion sort a quadratic running time. The average case is when the array is randomly sorted, still at least pass 1 two comparisons needs to be done and the hence quadratic running I order of n square. This is the instance sort in the particular image. You can see 2 is less than 5, so 2 is in a sorted list, and like it is 2 4 5, next 2 4 5 6 1 2 4 5 6, at last 3 also come in the sorted, and last array will be 1 2 3 4 5 6. Before it was 5 2 4 6 1 is unsorted list. Next we can selection sort. Algorithm divides the input into two lists, as you already know. Next we will go to bubble sort. Bubble sort is a very simple method that sorts the array elements by repeatedly moving the largest element to the highest index position of the array. In bubble sorting, consecutive adjacent pairs of the elements in the array are compared with each other. If the element at lower index is greater than the element at the higher index, the two elements are interchanged to the smaller element is placed before the bigger one. This process continues until the last list of unsorted elements exhaust. Like in the right side of the picture, you can see 0 6 5 8 7. In a bubble sort, the heaviest items sinks to the bottom of the list while the lightest float on the top. Next we can see the technique. It is in pass 1 compared, in pass 2 are compared also, in pass 3 not and a1 are compared. If we pass n minus 1, a of 0 and a of 1 are compared, so that a of 0 is less than a of 1. After this step, all the elements of the array are arranged in ascending order. Next we can see bubble sort algorithm. Loop on pass index. Initialize the exchange counter for this phase. Step 3, loop for iterating from start to end. Step 4, make pairwise comparisons on unsorted elements. If a of j is greater than a of j plus 1, then a of j is a of j plus 1. Exchange plus 1. Where any exchanges made on this pass at last terminate, return. Analysis of bubble sort. In bubble sort, we have seen that there are total n minus 1 passes. If the first pass n minus 1 comparisons are made to place highest element in the correct position, then in pass 2 there are n minus 2 comparisons. F of n equal to n minus 1 plus n minus up to so on 3 plus 2 plus 1 at first order of n square. Bubble sort complexity is order of n square. And this is some picture you can understand by seeing it. Next, divide and conquer. Divide and conquer is a recursive structure. Divide. The problem is into several smaller subproblems that are similar to the but smaller in size. Conquer the subproblems by solving them recursively. If they are small enough, just solve them in a straightforward manner. Combine the solutions to create a solution to the original problem. Next we can see the merge sort. Merge sort is a sorting algorithm that uses the divide, conquer, and combine algorithm paradigm, where divide, conquer, combine as we already in the previous slide. Merge sort algorithms focuses on two main concepts to improve its performance. A smaller list takes few steps and thus less time to sort than a large list. Less steps, thus less time is needed to create a shorter list. Sorted list if from two sorted lists rather than creating it using into unsorted list. In my technique, merge sort technique, if the array is length or array of length 0 or 1, that is already sorted. Otherwise, divide the unsorted into two subarrays of the about half size. Use merge sort algorithm recursively to sort each subarray. Merge the two subarrays from a single sorted list. It is a merge sort like first 14, 31, 24, 5, total 8 elements n by 2. 8 by 2 4 4 4 after 2 2 2 after solving the each problem combine the solution, we can get 4 7 14 25 31 32 like in a sorted list. Merge sort algorithm is you can see that this is also some analysis of merge sort. Analysis of merge sort. T of n equal to 2 of t n by 2 bn plus c. Order of n log n, best, average, and worst. Three different cases are the same in merge sort. Next we can see the quick sort. The quick sort algorithm works as follows. Select an element pivot from the array elements. Rearrange the elements in the array in such a way that all elements that are less than the pivot appear before the pivot and all elements greater than the pivot element come after it. After such a partitioning, it is you can do not understand by this seeing the definition, but you can see the example. It is algorithm. You can see the example. Input is P65, that is a pivot element. It will be swapping. You can see the image items smaller than or equal to 65 items. Right side items are greater than or equal to 65. Analysis of quicksort. The advantage of quicksort is that we can sort in place I without the need for a temporary buffer depending on the size of the inputs. Basic quicksort relation is T of n equal to Cn plus T of I plus T of n minus I minus 1, where I is the size of the first subblock after partitioning. Worst case, this happens when the pivot is the smallest or the largest element, then one of the partitions is empty and we repeat recursively the procedure for n minus 1 elements. Best case. The best case is when the pivot is the median of the array and then the left and right part will have same size. There are log n partitions and to obtain each partition we do n comparisons and do not more than n by 2 swaps. Average case. Worst case of quicksort, same as I also mentioned. Best case of quicksort, divide by n on all equations. Therefore, T of n equal to order of n log n. Trick is to select best pivot. Different ways of choosing a pivot. First element, last element, median of 3 elements. Pick 3 elements and fix the median x of these elements. Use that median as a pivot. Random element. Randomly pick a element as a pivot. Thank you.